All right, so last video I was talking about just indexes in general and how they're used to find data in a database quicker because it's stored separate from the data in the database in a B tree, and this B tree can be referenced to find where the index is, and this index in the B tree will reference where the data is stored in the actual pages of the database. And this is kind of simple to understand when there's no partitions. So let's say a single table, it has an index, and all the rows in this table, they're confined to just one database. So this is like logically simple. It's just a single database. Let's just say we have a single B tree because we only have one index, and this is all in one computer. So there's no network latency. Simple, life is easy. But at scale, we need to partition our databases. And so partition each table, we'll say, because if there's a users table and there's a million rows, eventually it's going to become so much storage that we can't even just store this on one device. So we're going to have to partition this across multiple different nodes, different databases, which each hold a portion of the data for that table. Now, when we have a index in that table, this gets a little harder. And this is where local secondary indexes and global secondary indexes come in for NoSQL. And you guys have probably heard of these terms. And local secondary index, this is similar to just index where there's only a single computer that we talked about last time, because there's multiple nodes and they're each responsible for a portion of the data. We'll just say for pedagogical reasons, the first node is responsible for ID 1 to 100, second node 100 to 200, third node 200 to 300. So a local secondary index might be where, it's only searching between 1 and 100 ID. So this B tree, which is storing references to where the data is stored for each of these indexes, 1 to 100 for ID, this will be stored just on this one node because it only matters to this one node. The other table or the other databases aren't concerned about row 1 to 100. They're just concerned about row 100, 200, row 200, 300. So they'll each have, let's say, local secondary indexes for their portion of IDs. So whenever someone looks up, okay, where's the data for ID 70? This will be hit to the first node, and then this first node will just reference its B tree, which is a local secondary index, to get the values or the reference to the data, which stores the values on that first node. So this is local secondary indexes. Now, global secondary indexes, kind of similar as well to just what we talked about last time, but in this way, there's network latency. So there's just one table, we're saying, and there's just one index, but the data is stored on 3 different nodes. So what if we wanted this index to just be stored in a single place? So when someone says, let's say that the index is name, select something where name equals this, and the name is a global secondary index. Now this B tree, which is storing all these indexes, is stored in some global node that is referenced from all these nodes. And anytime someone wants to find something where a name is this, they have to reference that global secondary index. So the reads are slower because the network latency, and also the writes are slower because we have to uphold the integrity of this global B tree every single time any of the 3 nodes are wrote to.